at our latitude, which is 43 degrees south, we don't get a lot of sunshine this time of year. So to grow things, firstly, a greenhouse or hothouse is important. But I'm also just thinking about the amount of light that's available. So I was thinking about a project where I might maybe harness some of the sun's energy during the day and give it an extra half hour or hour at night time with a grow light. So this is a grow light here. So it was sold as a full spectrum grow light, which is interesting. And this one here is just a standard 12 volt LED. So I'm going to compare the two side by side. This one, I'm pretty sure I can just plug straight into a 12 volt supply. So we'll try that. But this one will require a current limiting resistor. I just happen to have a 2 watt, I think it's a 18 ohm or 20 ohm resistor. So that'll be saddled onto this guy, and then we'll plug it in and see what it looks like. Here's your standard downlight, incandescent, not LED, 12 volts, 50 watts, which is a lot of energy. And most people, I guess, would be replacing these sort of downlights in their houses these days with the more efficient LEDs. But this is obviously broader spectrum, which we'll see in the analysis too. So maybe suitable for growing plants, but yeah, at the expense of a lot of energy as opposed to being targeted like, for instance, a grow light might be. So we'll see how the spectral analysis goes, and we'll see how it compares with the actual grow lights. So the 50 watt LED obviously provides enough light for us humans at night time, but the question is the frequency right? This is the grow light. It's only 3 watts, and I've hooked it up with an 18 ohm resistor on one side. And if I've done my calculations correctly, that should give us a power rating of around 1.5-ish watts. And the grow light itself is rated to 3, but the resistor I've got is only rated to 2. So, and I've blown up enough things today already, so I don't really want to push it too much. So what we'll do is we'll just pop that in there, and we'll see what it looks like. Okay, yep, so 6.5 volts, around 1.3 watts, and slightly warm, but not too bad. But clearly a different spectrum to the standard LED. You certainly wouldn't want these in your house to light your way. What I don't know is that is this just a single frequency or a combination of narrow frequencies which doesn't match up with chlorophyll? So the spectrum that we get from the sun covers a fair number of frequencies. There's some dips in the absorption there because what you have is chemicals in the upper atmosphere such as water, ozone, CO2, all these sorts of things, and they will take a little bit of that spectrum away, but basically it covers the full range of frequencies. And the commercial lights, grow lights that you can get, do tend to hit those frequencies that chlorophyll is looking for. So chlorophyll, obviously with its colour green, is looking for a fair amount of green, but there are different versions of chlorophyll, and yeah, it does depend on different plants and combinations, but basically it'd be pretty useless to have, for example, just a purple light. So what we're really looking from here in the spectral analysis is covering some of those frequencies that chlorophyll is looking for. So let's do that analysis, and then we'll know whether or not these were worth it for the grand price of, I think it was $9 for 50 of them delivered. Pretty good. Yeah, just wanted to point out as well that if I do use these, then I'll be mounting them properly with these little aluminium heat sinks, and even perhaps a little aluminium block underneath. It wasn't really enough to save this one, although, as I said, it was the resistor that was the problem. If I replace that, I think this will still be fine, but this one blew out because I was running it at 3 watts and this is only a 2 watt resistor, so there's a little bit of damage there. Yeah, the best way to run these LEDs is to have them on a heat sink, and in my case with a heat sink underneath as well, and that certainly will provide more protection. I've got a load of 3 watt and 5 watt resistors on their way to take the heat off these 2 watt resistors that I've been blowing up pretty regularly in the quest to find out whether or not these grow lights are the real deal. So yep, let's go check that out now.
Here's the spectrum coming in from the sun, and you can see in the visible region here it's pretty solid across the board. There's a few dips here and there which would be the chemical compounds which are found in the upper atmosphere, just taking out the odd frequency, but basically it's pretty strong across the board. And land-based plants on this planet mostly contain chlorophylls which pull that light out, and you can see that the region that they're most interested in is the 400 to sort of 500 mark. You see there's quite a few peaks in that region. Not much in this region here, between about 520 and maybe 630. Then a little peak here between 650 and 700. So the commercial grow lights that I've been able to find on the internet anyway, that do publish their spectrum, they have this sort of output, and if we overlay the chlorophyll requirements, it's pretty interesting. I mean, you do see that sort of peak up here in this blue area, and that's obviously going to suit these chlorophylls, although interesting, it comes right in the gap there. And then you've got this enormous amount of energy through here, which is really wasted in terms of grow light, because it's not required. And then of course you've got this peak out here in the 650 to 700, which actually looks pretty good. So how does that compare with what I've got? Well, this is the analysis that I did, and the blue light represents that sort of 12-volt standard house light, and the red light represents the 3 watt grow light that came in from AliExpress. I've got all the numbers over here if you did want to pause it and have a look at those, but I'll just move on to the actual spectrum itself. And again, what I'll do is overlay the requirements of chlorophyll. So yeah, not much better than the commercial ones really. A little peak here, but the blue light here is quite stronger because effectively because of the strength of the light. So you'd probably more likely find that to be down here if it was a comparable light around the 3 watt mark. But this is operating around the 50 watt mark, so a lot of light provided here, but then of course a lot of power required as well. This little 3 watt guy, it's doing pretty well. You can see also there's a peak in this blue area, and that's certainly what's required by the by chlorophyll. But then you've got this big peak and not much out here being used, so that's probably a lot of wasted energy from about the sort of 540 nanometer mark onwards, and then all the way through, and then both of these lights tail off pretty well, and not much use at all. I'm guessing probably up around this, a little bit available there in the 650 to 700 nanometer. So yes, probably the next thing to do is to actually put some plants under, well, certainly the grow light, and see if it's going to have an effect. So that's the circuit working for this week. See you next time.